So here we are, we're at the Radial drill press. I'm about to put my part in the vise, and this is the last time I'm going to mention this. I'm going to make sure I'm clamping across the factory edges here because they're going to be more parallel than our saw cut surfaces. And I'm going to put the 6 o'clock hole on my side of the vise. Now let's talk about all of the controls that you're going to find on a radial arm drill press. You will also notice that the 3 drill presses we have here in the shop, they are slightly different, but they all do the exact same thing, and the levers are more or less the same position. So what you see here, you can generally apply to other radial arm drill presses, but if you ever have questions, just make sure you stop and ask. The first thing is talking about what is a radial arm drill press and how is it different than a regular post type drill press that you'll have in your standard shops and wood shops and also machine shops. The first thing is just the size. They're going to generally be a much larger piece of equipment and they're going to have more power, so it's going to be better suited for the bigger diameter drill bits that we are using in the machine shops. And then also it takes a lot more strength or horsepower to put a drill through a piece of steel versus a piece of wood. Now the radial arm function is referring to, if I lift up on my lever here, this releases the lock of my column. And then now I can pivot the whole arm. Whenever we're not moving any part of a piece of equipment, we want to return the clamps to the lock position. On this machine, to lower the arm, all I need to do is push down on this lever here, and we will see motion. Up goes up. It's pretty simple. What we have to be aware of is this machine does not know where the part is, where the table is. It doesn't know anything. So if you are lowering the head or raising the head, you have to be paying attention that you're not going to be running into anything. Next, we'll look at how we can move the head back and forth or in and out on the arm. This machine's lock is located on the left side of the head, and what I really like about this smaller radial arm drill press is just with the finger strength I can move the head. Now of course you see the hand wheel moving, and that's designed to be used, but what I'm trying to illustrate is this is a pretty agile machine, and some of the bigger ones that we have in the shop take a lot more strength to get them moving. Now, of course, the reason behind all this motion is so we can position our center, the center of our spindle, over the location that we want to produce our holes. So, this right here, what I just lowered down, is our spindle. Either we're going to be loading a taper shank, a Morse taper shank drill chuck into this spindle, or maybe we'll be putting a drill bit that has a Morse taper shank directly into the spindle. And you probably still remember from our first drill sharpening instruction, we only hold straight diameter shanks in drill chucks, never taper shank drills. In this case, we're going to be loading up the correct center drill as instructed by the order of operations. Now the handle of this drill chuck is being stored with it lightly clamped inside the drill chuck, and I'm okay with that. But when this drill chuck is in the machine spindle, we never want to store the drill chuck with it engaged into the side ports of the drill chuck. Because what I want to do before I load a tool holder into a spindle is I want to ensure that both the mating surfaces of not only the tool holder but also the inside of the spindle are clean. This towel is free of chips. It is a little dirty, but it's not, there's nothing stuck to the side of it. So I can stick it up into the spindle and give it a little spin, and now I'm pretty confident that I don't have any debris inside that surface. Now that debris would cause dents to form in our softer material on our taper shank on our drill chuck, and that's a bummer because we're lowering the accuracy of our tooling. But my biggest concern is actually that if I don't have full engagement on my mating surfaces, then this drill chuck could arbitrarily fall out of the spindle while I'm drilling holes. So I might be drilling away and then retract my drill out of the hole, and at that moment when the drill tip's leaving the end of the part, it just catches a little bit and then it finally gives way, and then all of a sudden you have a chuck with a drill that's maybe spinning 600, 800 RPMs and it's falling. If you ever find yourself in this situation, what you want to do is step back and just watch out. It's going to be very difficult to not reach and try to catch something that's falling, but you need to start mentally preparing yourself in the machine shop that if you see something falling, pretty much you need to let it fall to the ground. Best case scenario with the spinning drill bit, you might catch it, but guess what? You're probably going to have cuts on your body and maybe require some sort of stitches or medical attention. And more likely than not, you're going to drop the part anyways after it cuts you and it hurts you. So mentally plan ahead and say, if I see something falling and it weighs a couple pounds or more or has sharp edges, I'm just going to watch that something hit whatever surface it is. Your safety is more important than the tools, so just try to have a game plan before something happens. One last thing, I did mention that nothing is holding this inside the spindle except for the shallow taper angle. A shallow taper like this is considered a locking taper. And after I seat this tool holder up in the spindle and then I gently tap the face, the wedging action that's taking place will actually put a tremendous amount of clamping force down on our tool holder. So as long as the surfaces are free of debris and they are the correct angles, these tools aren't going to just fall out. It's damage to a tool holder or debris in a spindle that's when you start to see things go bad. So let's go ahead and load up this tool. What I'm going to do is I'm going to lower this spindle. I'm going to bring the camera over so I can show you how we need to orientate our tang to our drive slots inside the spindle. Okay, so here's a close-up of our spindle. Here's our tool holder. There's the drive tang. Tool holder goes up into the spindle. You can see now it's all lined up. And then what I would do, now I seated the tool holder into the spindle and I got a good firm impact, but as an extra layer of safety, I'm gonna kind of firmly tap the end of my drill chuck against a block of wood, not just my surface of my metal. And you can see I didn't get carried away. I gave it a couple good thumps, so now I feel very confident that tool holder is not gonna fall out. Let's talk about how to unload a tool while we're on the subject. I've lowered the spindle down and I have my port window lined up. So now I can take a drift, and normally these have a slightly better radius on the top, but this one's been loaded in incorrectly. The radius side should go up. But I can slide the drift into the port and then observe how there's a short gap right here because the drill chuck is going to fall. And I can give it a few gentle taps, and then the drill chuck fell down. Of course, if I was over or not over the table, it would have fallen to the shop floor. So we want to go ahead and put a block of wood underneath it so that way it's not going to hurt anything.